Hello, my name is Maverick Collins. This is my video submission for the gritty technique on solving the knapsack problem for CST-201 with Professor Woodward here at GCU. And in this problem, we were given these three arrays: weights, value, quantity, and we were giving a max capacity for our knapsack. And we were tasked with building two solutions that would optimize the amount of items we can carry in a knapsack. And here's some references here that I use to help solve this solution. So we had a weight capacity of 280, and each item had these corresponding values with them. So item one had a quantity of one with a value or worth of 70 and had a weight of 20. So I guess we're supposed to run this first. Let's just run it. Okay, so there's the solution. So anyhow, the task with the knapsack problem is how do we optimize what items to pick and store in our knapsack that are worth the most that also fulfill our constraints. In this problem, our constraint was the weight capacity of 280 and that we only had these corresponding quantities to take of each item. So there's 6 items. So here is the business logic here, knapsack solver. Baldung was very helpful for helping kind of frame out the bones of this. And our main driver is running this. And here you can see we're comparing the dynamic programming solution with that of the greedy solution. So you can see dynamic programming is far more accurate. However, it takes significantly longer. You could see that it took 2,200 steps in comparison to that of the greedy algorithm, which only took 6 steps, with only a negligible difference in the amount of optimization. So the dynamic programming had a max value of 650, where the greedy technique, right, it's just based off of the locality of each item and it makes a decision quick, and it came up with 630. Time complexity of this is, I had to look up this on Stack Overflow for dynamic programming, is roughly like polynomial time, big O of polynomial, n squared, specifically number of items times weight capacity times maximum quantity. Whereas with the greedy solution, it's n log n, so a lot more efficient. This is important if you need to quickly optimize a set or a solution, or like say for the traveling salesman problem. The greedy technique takes the cake in terms of resource management, optimizing, memory and time. Whereas if you need a more exact approximation, dynamic programming is going to be the way to go. Thank you for your time for watching this solution, and we'll see you in the next one. Thanks.